a little bit about what's the strategy? What does it mean to take a new product to market? What do you think about as you've been in this space a bit? So first of all, this term gets passed around a bit. So I'd like to hear kind of what you guys think. What does it mean to you?
Sure. So let's see. When I think of MPI, I sort of look at it from a big picture of what are the different steps of going from an idea to a product on the shelf. And you could break this up into hundreds of different sections. But for me, I kind of group it in three main buckets. So one is the idea to the prototype, which is, can you just get the thing to work? Which is hard enough, I know, from the candy machine. Then the last phase is, once you've got it working, how do you improve the quality and reduce the cost? And the middle phase, by definition, would be the MPI. So how do you take that prototype and then think about scale so that, well, we'll talk about all the different parts that go into that, but sort of bridging the gap from one to many, but not quite optimizing it for incredibly high volume.
What's your note? Sorry. Yeah, no worries. Yeah, my take is very similar to what Scott just said, but of course, I come from the supply chain side of things. So to me, it's what is needed, for somebody to put a plan in place so that you can get your product, to the market on time, on cost, and on quality. So a good MPI will allow you to achieve all of that. But of course, this is coming from my side of the view, which is the supply chain operations and manufacturing side. And I think Jay will have a different take on that.
Yeah, I think I agree with everything everybody said so far, but I would say it's having a plan. What is your plan to get from where you are, which is either an idea or a prototype, to actually something that's out in the world, being a product for somebody? What is that plan? And there's a lot of steps along the way to get there, so need to have a plan.
And with that, why don't we kind of jumped right in, but why don't we kind of go backwards and talk about why you guys are up here? What is your backgrounds? And
so my background, I'm here for technical program management. My background is about 30 years in the electronics industry in Silicon Valley. I'm a double E by training, but pretty early on started working and kind of naturally getting involved in managing development projects. Over time, I have led various hardware and software engineering departments and built program management teams for companies like Logitech, building webcams back in the early 2000s and late 90s. And so I've seen the process from beginning to end, from the marketing concept all the way through production launch many times. So kind of been there and done that. And these days, I spend my time helping small companies figure out how to get through their process, get their product to market.
and your name?
Oh, sorry? My name is Jay Feldis.
And with product realization.
Yes, I'm going to start with, my name is Bob. So I'm also from Product Realization Group from Silicon Valley. My background has been about 18 years kind of running operations and manufacturing for tech companies out of Silicon Valley. Had a couple different successful exits. And my primary job is to make sure that what is designed by the engineering team is manufacturable and it's delivered on time and launched properly to the marketplace successfully. So I've been doing that a couple different times, and just like Jay, coming out here to understand a bit about the Shenzhen ecosystem and see how can we bring that kind of knowledge to Shenzhen as well to bring out the startups here.
So my name's Scott Miller, and I'm with Dragon Innovation and also Bolt. For me, I'm a mechanical engineer by training, or I guess more accurately, an ocean engineer. And I've kind of followed the progression of designing things and then falling in love with trying to understand how they're manufactured. So I've worked on everything from robotic tuna fish, where we were trying to figure out how to get greater efficiency out of undersea vehicles for the US Navy. And if you look at a fish swim by versus a boat, it's pretty obvious which one's better. So we ended up building this pretty cool 49-inch tuna fish based on a real tuna fish back in the mid-90s. And things were so primitive back then, like the CAD was in its infancy, that we actually had to buy a real tuna fish and sliced it into 1-inch steaks and basically like traced the outline and then lofted the thing together to get the hull form. So it's funny how fast things have grown. That was like 25, it wasn't that long ago on the scale of things. But then went over to Walt Disney Imagineering and led a team that built a full-size walking robotic dinosaur. So imagine a 12,000-pound, 12-degree of freedom vehicle powered by a Corvette engine. So did that, so sort of a lot of design stuff. Where I got my manufacturing experience was at iRobot, where when I joined it was called IS Robotics, and we did everything from fish to underwater acoustic modems to Lisp garbage collection. So no idea what the hell we were doing, but one of the things we did do is get a JV with Hasbro to build an artificially intelligent robot baby doll. And I, being the ME, kind of got thrown into that, and of course we're going to build in volume. So I was shipped over here. I met my co-founder, ultimately Herman, and Dan Long, who are working at Hasbro, and then together we figured out how to build about 100,000 of these. And at that point I just became fascinated with China and high volume. I was able to translate that sort of experience with Herman and Dan into the Roomba and manufacturing that. So moved over here for 4 years back in the early 2000s, and then as a team we built about 4 million Roombas, so we could bang out 40,000 a week, which is roughly, it's about 10 containers, so about twice the volume, 2 or 3 times the volume of this room every week. And when you think about having a little bit of an oops and then multiplying it by 40,000 times, you get a really big oops. So we made a lot of those mistakes, and we had the joy of fixing them. So I learned a lot in that process. But did that for 10 years across 8 different robot introductions. And then with Herman and Dan started Dragon about 10 years ago to help companies go from the prototype to production. So things like Dropcam, Fitbit, MakerBot, Formlabs, Sphero, Ring, and I think 300 or 400 at this point. So that's what we do. And then also started as a small part a VC fund that invests in hardware. So I got to see what it's like on the other side. So.
You know, that'll be a story for another panel, but I would like to hear that one too. So, you know, these guys are some of the experts here. It's a real treat tonight to have, and I'd like to start with, you know, the NPI is about this plan, right? And I think one of the things that I see with hardware startups is, and we talked about this last night and earlier today, but it's the unknown unknowns that often really kill the business, right? And it's the plan that didn't cover. It's what was left out of the plan that is often really the hardest part, right? And so, you know, you guys want to talk about how do you look at it kind of from a high level? How do you look at the strategy of new product introduction? How do you break it down a little bit? And maybe we can go back.
Sure. So there's a lot of different things that go into it. I'll just talk about the manufacturing part, but there's a whole product market fit and marketing and sales, which I won't focus on. But for manufacturing, the thing that we know that's going to kill a company is running out of money. If you don't run out of money, there's a pretty good chance you can, you know, live to fight another day. And thinking about the unknown unknowns, which are incredibly scary because obviously you don't know what you don't know, what are the main ones that are going to impact your financial health? And for us, what we find is everybody is so focused on the cost of goods sold, and they may or may not be able to calculate what that is, but they kind of have an idea like, okay, I should probably know how much I'm selling the product for and how much it costs me to make. But the thing is, they don't factor in the fixed cost. So whether it's working with a great partner to help with design for manufacture and assembly, like the Berkeley Sourcing Group or things like that, you have to account for that. You have to account for tooling. If you need a radio in there, you probably have to get some compliance, which is going to take time and money. So being able to capture not only the variable costs, but also the fixed costs is really important. And then once you've got those, understanding the cash flow or the payment terms. So for example, if your factory requires you to pay 70% of the component cost when you order the components, and the components have a 16-week lead time, you're writing some really big checks up front. And then maybe, and you shouldn't do this, but maybe you're selling to Walmart and they're going to pay you 120 days after they get the product. So you've got a huge amount of money that you've got to bridge. And if you haven't understood how much money that is or the payment terms, then the minute you get a big order, you can bleed yourself dry, which is incredibly frustrating because you've worked so hard to get to that point.
Really quick question. What puts you in a worse cash flow situation? Is it if you have great sales or if you have almost no sales? Serious question. And there's an answer. If you're super successful, you will be in a terrible cash flow situation because of this, because of the payment terms. You don't get the money for longer, but you have to pay for more inventory, right? So this is a really interesting situation about this. Is you think you want all the success, but success is what really burns a lot of companies out.
Yeah, and to that point, I think like if you have somebody on your team that's very good on the financial side, and then can work with kind of cash flow projections, that helps a lot. Knowing what your partners expect and your clients expect in terms of terms, and then aligning the right kind of financing to make sure that that happens, right? And so my job is typically on the supply chain operations side. We work to reduce risk. So it behooves you to find the right partners that can allow you to scrub through all your plan and making sure that you cover all your bases. So for example, like to the point about, oh yeah, you just realized that your component is 16-week lead time. So way ahead of time, you work with your engineering to come up with risk assessment plan for the components that will go into your product and say, do we have alternatives that could alleviate that? And that's a lot what supply chain and operations does, making sure that there's no nasty surprises for you when you go to market. There wouldn't be something that will kind of trip you up, right? So it's all about risk management.
And to segue off that a little bit, because of those lead times, which can be 16 or 18 or 20 weeks, and you start putting that into your development schedule, you'll find out that you're having to spend a lot of money on parts really, really early in your development process. And sometimes that's surprising to people that, oh my God, I just started designing this and now I have to buy the parts. Yeah. So, and that gets back into the part I wanted to talk, which is more the front end, which is what is your upfront work that you need to do to make sure your project goes well, and that's very much about defining your requirements, defining your market. Who's going to buy this? How is it going to get sold? Who's going to use it? And writing all of that down into product requirements document and being very clear about that. I know that sounds obvious, but I would say probably 3/4 of the companies that I work with have only done a sketchy job of that. And if you run and start developing without being clear about what it is that you're trying to do, you end up sometimes missing your target or making wrong decisions or having to make changes halfway through the project. And now you just bought a lot, 100,000 pieces of some material 20 weeks in advance, and it turns out you don't actually need that part because you changed your design halfway through. So thinking of these things and learning as much as you can up front and putting that into your design and planning that you're going to have to freeze that design probably the first quarter of your product development cycle is really important to realize as you go in.
And you brought up the idea of the product requirements document. I think it's probably the most overlooked thing that as far as the document goes, and especially as far as if you're using a good template, it'll help you identify where the gaps are, right? What is missing, and help you figure out what those unknowns are. But documentation is a really key part of all this. And maybe Bob, do you want to talk a little bit about like how you approach the documentation problem? It seems like there's no universally accepted.
Correct.
Everyone uses something.
A lot of people think about documentation sometimes after the fact, when somebody comes into the team and say, "What's your documentation?" Oops, that kind of thing, right? So it's very useful if as Jay said, right up front, you start thinking about how are you going to build your products. So first of all, of course, the specification for your product. You figure out your product market fit and all the great stuff, so you know what will go into your product and what functionality will go into your product. But for me, what I find that after you realize that what your product will do, people totally forgot about how am I supposed to build this product, and do not have documentation how it's done because they did one-off. To your point just now, doing one seems to be easy enough, but then how can you repeat this, for 100,000 units or 1 million units? You want to do it efficiently and all of that, and that requires you to document, how this product is being made, and then put that as part of a closed loop of your product design as well. And that's sometimes one of the things that get forgotten.
Yeah, mean, for us, the documentation is, of course, incredibly important, and you're sprinting so hard, say in my case, to make Halloween, or in the case of most companies, to make the holiday season, that you're just trying to get the thing to work and praying it works, not in 1 and 2, but in a larger quantity. But for us, we find really the foundation on which you're going to build your house is the bill of materials, or BOM. And what we've seen in working with hundreds of companies is most of them are going to start in an Excel spreadsheet or a Google Sheets, but they're going so quick they just don't update what they did, and ultimately they just don't have a good feel for what goes into the product, so that if they had to actually build it, they may not even know the core ingredients, which is one of the reasons that Dragon we ended up building this thing called Product Planner, which basically lets you keep track of the bill of materials with things like MOQs and lead times and approved vendors. Because if you're buying onesies or twosies, you may buy it from DigiKey, but if you're buying 10,000 of them, you might buy it from a different source like Avnet. And that's just a pain in the ass to keep track of in a spreadsheet. You could do it in enterprise software, but that's so expensive and so slow and unwieldy that it's not going to help you get to market really quickly. But just being able to keep track of that stuff.
And this component sourcing, right, it's just a pain in the butt, right? Talk about
Yes.
your experience.
Well, I was just going to say, just this week was in a call with a client who lost 2 weeks on their project launch schedule because when someone updated their spreadsheet, they didn't update the name of the part and on the spreadsheet, 2 parts, and the manufacturer built their first round of samples with the wrong part, and everything blew up and it didn't work. And it was, as soon as they saw it, they knew what it was, but they lost the time. And you do that a number of times and you're in bad shape, right? So that's a big part of it, yeah. And in terms of sourcing, yes, I mean, finding parts, finding them quickly, finding what's available, it's a very big deal, a very big part of the process that has to start very early from the time that you've got your prototypes. You may have built one on the bench that works great, but can you find that part in volume? Yeah, you bought one off of DigiKey, you got it, it works, but is it available in quantity, 100,000? You have to find that out pretty early on.
Yeah, lead times, availability, the distribution and availability, not only like in the US, but in China, those can be totally different, and having the right resources to keep track of that and know where that you're going to get those can make a huge difference in your pricing, and especially your lead times, and making that feasible. So startups, there's this ideal vision of how all this stuff should work, right? You have all the perfect documentation, and you got the big team that has really dug into everything and has all the experience, which doesn't match with reality at all, right? Startups, so you got maybe a 5-person team usually, and you have some experience in some things, and you're going to have to cut corners, right? You don't have the money, you don't have the time. You can't do it by the book, right? What are you guys' thoughts on the strategy behind that? How do you choose which corners to cut? How do you look at that?
Yeah, so we basically look at it 2 ways. As Bob mentioned, we think of the manufacturing triangle, which is cost, quality, and schedule, and they're all interrelated. You can imagine if you spend more money, you can get better, say maybe a better schedule because you can pull in the parts, or better quality, but you might suffer on margins. If you go quicker, your quality may suffer, and so on. So it's how do you balance all of those is one equation we're weighing. And then the other one is back to risk management. So you're going to make 2 types of decisions. One type of decision you make and you get it wrong, there's still a chance that you can fix it later. So those aren't that serious. The other one you make and it's going to cast a really long shadow, or it's going to be very difficult to unwind. So I'll give you an example from the candy machine because it's easy. So I decided to use a certain type of material for laser cutting. It's a Glowforge proof board or draft board. And the whole thing, probably took me, I don't know, 15 hours to bolt together. If for some reason I picked a material that wasn't strong enough, so the motors were falling off of the board or it was fracturing, then I'd have to go and change all of my design to either make it thicker for a more robust material or start all over again and re-laser cut everything, which would have been a major setback. Or if I had ordered a component, like suppose I designed for a processor that was going to be end-of-lifed the next week and I couldn't get them, and had my whole code base designed for that, that'd be a tremendous setback, and it would probably cost me the company. So those decisions, A, I have to know about because of the unknown unknowns, and I have to get them right. But other ones, are a lot more forgiving. If I screw up, then I can go and fix them. So it's a matter of getting the important stuff right and then not sweating the other things, because as Greg was saying, there's just never enough time or people or money to do everything exactly right. So it's all making those trade-offs and understanding the severity of them in our point of view.
Yeah, I mean, so I echo what Scott said. It's understanding what is your catastrophic failure modes. And the rest of them is just noise, right? If you have a scratch on your product, you can always improve it the next round. But if that thing, causes life and death, your company's gone, right? Or, if you couldn't even get it out of the door, it's gone. So again, early on, when you make the plan, spend some time to kind of do a risk assessment of what is the possible things that could go wrong, and and then categorize that into catastrophic or non-catastrophic, and then focus your effort in alleviating all those risk points, because that could make or break your company.
Yeah, and I think this is kind of where getting people involved who have a little bit of gray hair and experience helps. And that there's not really a template for this. I mean, it's not like you can say this thing on every project is always you must do, and this is one you can always cut a corner. It depends very much what you're doing. And so you need to have people involved who've been around it enough and can see what the risks are. Say that's something that's a pretty big risk that's going to sink you, versus, yeah, there's small risk there, but we can manage it this other way, right? And that gets into a lot of things like what's the scope of your testing? How early do you test? Which tests are going to most likely to bring forward the types of problems you're going to likely to see, versus other ones that are more perfunctory. You should do them, but if you don't, maybe it's not the end of the world. So you need some people who've been around the block to try to figure that out. Because if you try to do a quote unquote perfect job, try to apply the kind of systems that a big company puts in, you'll never get your product done, because you spend all your time doing paperwork and doing documentation and testing. But on the other hand, if you don't have a plan to verify your product and to mitigate your risks, you're probably going to run into some big problems.
Yeah, just to add something. Yeah, exactly what Jay was saying. We could do assessment as much as we want, but don't forget, as the founder and the creator of the things, you are naturally biased, and you have a certain way of thinking, and you're like, no way that could happen. So that's why, all these tests, like black box testing, like a reliability test, will sometimes flush out things that you never even thought about. And so again, if you do your plan properly up front, make sure you leave some budget to make sure that gets flushed out, so that you might just flush out something that could have killed the product before it went to the market.
Yeah, when you brought up the time, quality, money, and I'm just really constantly amazed at how balanced those are. You really, if you try to push all three, it will not work, right? You can't have perfection. You have to have balance, and so you do need to think of that equation. And what do you have the most flexibility with? Do you have time, or do you have money, or what can you afford to work with? And that's a good thing to think about, I think. Another one with the testing, and I'd like to go into this a little bit more deeply, because I think it is really one of the most overlooked things, is we're all focused on the specifications and the product, but the interesting thing about testing is that it's really the translation. You have to do all this work to build the specifications of the product, right? But there's a whole different process of testing, right? The tool of testing a specification is a different thing completely, and so you have to go through this process of looking. Kind of in a very simplified version of every specification should have a test, should have a way to verify and measure that it is the product that you have designed and created. And kind of would like to hear you guys' thoughts, and again, kind of from the startup standpoint where you don't have, in testing especially, as much expertise or time to really go into the details. I mean, I've got a 1,300-page Duran handbook on quality control, at home, and that's just one of thousands of quality control handbooks out there probably, and for a startup to even try to read that alone would be, no way, right? So.
Yeah. So in my experience, quality is always the thing that's left to the end. Everybody's focused on the cost, and then they're worried about the schedule. And it's easy to say, but it's also true. You should focus on quality first. And I'll give you a reason. So suppose you build a product that has a battery in it that can store significant energy, or you build something that plugs into the wall, like a battery charger. Well, there's enough energy in that to set somebody's house on fire. And if you build, we used to do 1 million Roombas a year, we can't pay $1,000 for parts for robots. So there's going to be some tolerance within them. And you are going to have a situation where something catches fire. How do you have confidence that the device is going to put the fire out and not burn down somebody's house? And when you sort of go it's one thing to be in a hardware startup and it's fun and it's exciting, but there's also a huge responsibility that goes with it, which I know I didn't realize until we had a wake-up call. And then everything changes because you're impacting other people's lives and health. So as you think about your quality plan, what are the things you need to put in place so you can sleep well at night, knowing you did right by your customer? So that's kind of the heavy thing. The easier thing is, the way I think about quality, you're eventually going to get an email from the factory saying, hey Scott, we've built 10,000 of these units, is it okay to release them or not? And you just have to be able to answer that question. You're yeah, they're good, release them, or no, they're not good, go fix this. And as I think about quality, everything should be designed in from the beginning to give you confidence that you can make that decision correctly. And usually the answer isn't going and doing an AQL or some sort of final shipment inspection, but you've got to know every step of the way that you built a quality product. Because maybe a way to think about it also is it's the fog of war. You never have complete data. And if you're doing a new product introduction, you don't have years and years of data. You're just getting to know this device. So you have to make the best decision you can with the information you have. And how do you get it right? And if you've put together robust quality systems or a good quality system, you can answer that, yes, release the product with confidence. And if not, you'll have a lot of sleepless nights. So.
Yeah, an important part of that is also your testing, reliability testing, your performance testing. And one of the interesting things, I guess it's kind of human nature, but you see a lot, is that, let's say I built my first prototype and I came up with some tests. Oh, I'm going to test it over temperature and I'm going to drop it on the floor. And I run that test and my unit passes 100%. Is that good news or bad news? When I hear that, I think that's not good news. You probably didn't test it hard enough. Because probably one of the most important things you want to get when you're testing is you want a failure. You want to know what makes this thing fail, because then you can fix it. If it doesn't fail, you can't fix whatever is wrong with it. And so it's really important that you structure your tests so that you do generate failures so that you can fix them and make the product better. Because what you don't want to do is find out those failures once you've built 100,000 of them. You want to find them as early as possible. And so you want to test early and often. So as soon as you have a prototype, think about what kind of nasty tests you want to do to it to make sure that it's going to survive down the road. Because it's really cheap to change that part when you've only built 1 or 2 or 5 or 10. It's really, really expensive to have to modify that design or change that part when you're trying to ramp production. So that is often overlooked. I've often had arguments with people, oh, we don't need that test. What do we need that for? It's going to be fine. I designed it. There's a lot of things that are not, the theory of the design and what actually happens is not the same. There's a lot of variation. There's a lot of interactions between parts that you're just not going to know until you actually test it.
Yeah, so as Scott said, right, you plan quality into your product. So you already know, how would you test the product and plan for that. And then as Jay said, then you also have to test it from what you don't know, right? You push it as hard as you can until a failure mode happens so that you know where's the weakest point of your product is. But as part of that as well, I think it would be very helpful if you have also phases of tests that you have in mind where you already kind of identify people that are not part of the core team that's developing the product to do, for example, what we call alpha, beta, testing, so that they can give you feedback from all the different, angles, right? Sometimes we joke about, like, why don't you just give the product to a 2-year-old, right? Because they don't even think like a typical adult user, and they will just lick it or whatever it is, put it in their mouth, and then just like, oh, I never thought about that. So, not that I want, to put harm on a little child, but their mindset is very different than ours. So the more you can get it out there for people from different background, different, gender, age group, whatever, so that they have different biases, then, you can, I think, test it as often and as varied as possible to cover all your bases.
Can I ask something? Of course. Because when he's saying about the batteries, I have bad experience before, so I'm very concerned now about the quality issues, not just for batteries, but for other things. Especially here, that sometimes we went very fast. Is the weight cap hole you have? What did you learn there? I mean, because you fix maybe a huge problem. Because I mean, if you are a startup, and you have quality issues, especially with batteries, maybe you run immediately. I don't know if you can do insurance or how do you find the way?
Right. Yeah, and it was lucky that the house did burn down, but we weren't at fault. It was terrible it burned down, but it was another problem. So what we find is that typically anytime you have the stored energy, like a battery, you plug it into the wall, you got to be careful. And what happens is often you'll use, say, a 4-layer board, which is just a sandwich with power and ground in the middle. And sometimes in China, the boards don't register perfectly, so it's not like a perfect sandwich, but it's more like the Leaning Tower of Pisa. And when that happens, you have less insulation separating the power from the ground. So it's possible for it to fail low resistance. So there's basically like 3 ways something can fail. It can fail open, so no current flows and no problem happens. It can fail short, and then hopefully you've got a fuse or a PTC, and it will trip the breaker, which isn't awesome, but you'll be okay. The thing that's dangerous is it fails low resistance, so say 3 or 4 ohms. And if you wanted to make a heater, there's no better way to do it than 3 or 4 ohms. So it absolutely will catch on fire, and it won't trip the fuse until you have flame. So the cause of that, again, is that either the boards don't stack up or register perfectly, or sometimes when they make the PCB on the mask, there's dendrites. So there's little fingers of conductors that sneak through and shorten that distance. So what I always assume is, like, the thing is going to catch on fire. Like, let's just take that for granted. So how do you prevent it? And the way you do it is there's an additive you can put into your resin called UL94V0. And basically, if you mix that into the resin and then put an enclosure over those boards, it will put the fire out. So it's one of those where if you know to do that and you design it in from the beginning, you'll get a great night's sleep. But if you don't, then you get that phone call, and then you've already shipped potentially a lot of product. And once it goes out, it ain't coming back. So it's really hard to fix it. It's not like software where you can just send an over-the-air update. So you've got to get that. But I guess I'd say if you remember nothing else from the things I can share myself today, UL94V0, put it in and put an enclosure around it, you'll be okay. Because it also gets tricky. Let's say you could build 40,000 units a week. I think my math is right in this. It's simple math, and they're $50 a piece. So you're writing a $2 million check a week to the factory. And then you put it on the water, so it takes 5 weeks to go from here to the Port of Los Angeles. It gets to a customer, and then they use it for a few weeks before it breaks. So in that 10 weeks, I've been shipping 40,000. So I've shipped 400,000 units at, what did I say, $50 a piece. So I've just written $40 million of checks, and I realize they're all bad. So like now I'm bankrupt. And the best case is I'm bankrupt. The worst case is I'm bankrupt and I have a lot of lawsuits. So it's one of these where quality, seems like kind of an abstract thing, but it actually gets to be really serious for the health of your company and the health of your customers. So you want to make sure, like, the important decisions you get right, like the enclosures over electronics, or for kids, pinch points or drop test or sharp objects. A lot of, like, an interesting one, we used to work with this factory that would do a lot of cut and sew. And what they made baby dolls, with hair. And I don't know if you've ever seen how they put hair in a baby doll, but they basically have the rotomolded head and then this medieval machine, which is like a sewing machine turned upside down. So the needle's like flying up and down, totally exposed. And then the worker will hit the pedal and kind of move the head around. And the needle's blind, like they don't know where it's coming out, and it's grabbing the hair and knotting it, it's something to watch. But occasionally the needles break, and you don't ever want to ship a doll with a broken needle in them. So with this case, it's a good factory. They x-ray 100% of the doll heads to make sure there's no needle. And every time the needle breaks, they have to stop everything and then recreate, like find all the pieces and put it together. But if you didn't know that and weren't watching the factory, more often than not, you're going to end up with some poor kid with a needle, in the best case, stuck in their hand, or like anything with razor blades or things like that. So again, it's easy when you think about it, but you're doing so many things, you may not think about it, and it may not be in the quality plan. So those things you just got to get right.
To share another story, so as Scott said, it's also good that if you have good partnership. I think that's very important. Like the factory knew to x-ray the dolls before it shipped out. So I had a project a couple of years back where actually there was a design fault, and the partner that they had didn't have enough finesse to do a good monitoring. So they had basically a high temperature test. They do a high temperature test for all the products before shipping out, burn-in test. And they didn't have a very good a sensor or a monitoring system. So what happened was the design error actually caused a short, and it burned the factory down. That was a catastrophic failure, right? So and luckily the company had enough money to recover from that, but not many people are as lucky as them. So maybe you have a blind spot, you didn't see it, but having a good partner, kind of like to try to cover as much of the blind spot helps a lot.
Yeah, and an interesting point of this, I think, too, is the timing of when you catch the problem, right? As you mentioned, in this case, but one thing we found in working with the factories is that if we're very good about specifying what is an acceptable product, then Chinese factories get a lot of bad rap for a lot of things, but we've actually had very good experience, and that they're if we've done our due diligence, we explain, hey, this is what we expect, we agree, this is the fair price for that. If you catch that problem with a good quality system at the factory, I'd say almost all the time that the factory's been willing to fix that problem at their expense. Right, but you take that same exact problem and you don't catch it at the factory, and you put all those on the boat, and they arrive to the port, and then get to your warehouse, and in every step of the way, it gets a lot more expensive, right? It gets to the customer has a return. If you even just catch it on the other side of the water, you've already promised your customers all of these units. They're all defective. In most cases, they're not worth shipping back, so you've mostly lost all of that inventory. And that's the least of your worries, because the much bigger problem is your customer's expected product on the shelf, right? So now you're paying double, triple to make product that can fill that stock, and you have to air ship it over, and you have to deal with all the phone calls from all the unhappy customers, and the product itself is a small fraction of the real cost to your business.
Yeah. And also what I've seen these days with online sales, it gets even worse in that if you're selling on Amazon, you sell even a small number that get bad reviews, and your rating goes down to 2.9 or whatever, something below, I think 3.5. It's almost impossible to get your rating back up, even if you fix the product, because people simply won't even buy it. So you're almost dead before you begin. So it's test early and often. Find the problems as early as you can. And I think this also leads into maybe segue a little bit into designing for manufacturability as well, and that it's not a matter of I did a design, I throw it over the wall to a factory, now it's their problem. If that's how you're thinking about it, you're probably going to run into trouble. Is you need to be thinking about how it's going to get built as early as possible, pulling in people who know, pulling in the factory as early in your process as possible, so that the things like the test points, like how it's going to be built, how it's going to be tested on the production line, how it's going to be verified, get designed in so it becomes something easy to do, not something that you couldn't do or is really hard to do.
So now you know why we say hardware is easy. Okay, well, I think let's open up to questions. You guys have questions for the panelists here? I can maybe walk the mic around if we have any.
Yeah, I was involved. I came from a software world, like 10 years ago, to a connected product team. As a founder, also as product manager of the team, I found myself stuck between CEO and also the engineering team. And the engineering team by themselves, they're split up into hardware and software. So my question is, what are the rule of thumb that to synchronize the engineering management between the software and the hardware part?
It is a great question, and it's hard. I think it depends on your situation, but because you'll have the software guys saying, oh, I can't develop this software because I don't have the hardware yet. And then you'll have the hardware engineers saying, well, this hardware won't do anything until there's software to run on it. And so you can stand there and stare at each other for a long time if you don't find a way around that. Often you'll want to try to figure out how to get a development kit going or some sort of early prototype going so that the software team can start actually coding. Even though it's not the final product, you can say, well, here's the chipset, here's the basic functions, here's a couple of LED blinky lights to represent functions you're supposed to do. Start developing so that by the time the hardware team has actually now developed a real prototype, there is some firmware to load on it. There is some software system to connect it to. And that's, you kind of have to iterate back and forth. And as a TPM, I can tell you I spent a lot of time, as you've probably seen, getting in the middle between those two teams to try to negotiate. There's a bug. Oh, well, the hardware guys, oh, it's a software problem. And the software guys, oh, it's a hardware problem. And sometimes it's one or the other. Sometimes it's kind of a combination of both. Maybe a misunderstanding about how the hardware was supposed to work, or vice versa. So that's kind of where you get in the middle as the project manager to dig in, have some enough technical know how to dig into the situation and try to come up with a process to debug and a process to get the software team to maybe develop some test code. You get maybe the hardware guys to be willing to swap out a part, to try to narrow down where the problem is and get past that roadblock.
That answer your question? Yeah, all right.
So yeah, just to add my own 2 cents, it seems as soon as the company gets beyond 10 people, communication becomes a huge problem within the company,
Yep.
and that causes a ton of problems. If you can get people to drink together, eat together,
Yep.
do team building exercises, whatever, that can help a lot, because a lot of times people get embarrassed to talk to each other. And then the other piece of advice is when you prototype, try to break everything. Like add the battery, add the case, like add as much as you can so that everything breaks and you can fix it. And then once you start manufacturing, change as little as possible. Yep. Right, but I want you guys to talk a little more about, I feel like in the field, the most common forms of recall are mechanical and firmware, probably, or software basically. And I'd like to hear some more stories potentially about like gotchas. I was like, the battery was great. I really like that one. But you sound like you had one. You talked about the importance of quality control, Jay. But I wanted to hear some examples.
Okay.
Put you on the spot. All right.
I think I can talk things like tolerance, especially coming from, if you talk about software people, when you write a piece of code, it pretty much works the same way every time. When you're designing a piece of hardware, there is tolerance in that. Despite all the best tooling and everything, there's going to be, as you go along, that the parts are going to vary a little bit. And so you can build 1 or 10 of them in the lab and they all work great. You can build even 50 or 100 and they all work great. And maybe you had one failure, but that was an anomaly, so you'll just kind of ignore it. I had this happen with a gearbox design that the prototypes all worked great, not too many had a problem. Started ramping up into production and started getting gearboxes that would jam, and we're trying to, now Christmas season's coming, we're already committed, we're rolling, we're shipping these. And you're starting to find out that 10 or 20% of the units have gearboxes that jammed. And simply tolerance variation. We thought the design was good, and when we actually started running it in volume, well, a number of them weren't. And I can tell you that's painful, because now you're trying to stick firmware, software changes to try to fix hardware problems, and trying to add components to try to limit things so you don't get in a jamming situation. It can be hellacious when you're trying to launch if you're into something like that. So, you got to think about that stuff. What is the tolerance variation, and how have you accounted for it?
So in that case, that was die casting that caused the issue, or?
No, that was, these were precision molded gears. These were plastic gears. And this was maybe the days before 3D printing, so there was a little less prototyping. But even so, it's a precise design, and if your molds don't come out, aren't sticking to the tolerances that you need, then yeah, you can have jamming. And so maybe your design should have accounted for that variance from the beginning, had a little more slop in it, maybe the gears were less efficient, or maybe you had to put tighter controls on your manufacturing process to make sure you're rejecting gears that are out of, can't tolerate as wide a range of variation. So
It's definitely true with plastic. I've seen a lot of parts come out as Pringles. Right? Because of cooling, sometimes they come out like a Pringle.
Yeah. Well, yeah, I think it was, I'm trying to remember now, but it may have been cooling related to the material and the cooling process. But, these kind of things do happen. You just have to have testing processes and validation processes and control systems to try to stay ahead of them, so they don't get you, if we had found this problem and really addressed it early in the development, it wouldn't have been a big deal. It was only a big deal because we're trying to fix it while we're trying to launch and ship out to Christmas holiday. So
did they have glass fiber in the injection or not?
now you're getting into details I don't remember.
Okay.
No, I don't think it was. Yeah.
Okay. All right, more questions. Oh my goodness. All right, here we go.
Maybe a question for Bob. Let's say you have a startup and you have the big problem of being too successful, and now you anticipate having a big cash flow. So because you've been using the product planner, you will have a cash flow problem. What is the likelihood of going to your supplier, your CM, and say, look, I like you, I have a big problem, your terms, if I keep those terms, I die. Look, I have my cash flow, I die here. Can you give me better terms?
That depends on who your partner is. So that's why I typically try to tell companies, when you look for vendors, don't treat them like an outsider. Don't treat them like an adversary. Especially when you're small, you really need the help of the community to be able to thrive and survive. And I will always try to advise people, when you approach a supplier, look at them as an extension of your own team, and try to work with them and build some sort of a trust. Because if you do what you say you will do and continue to do it, for example, you place an order and payment's always good, the supplier is more likely willing to work with you, because understanding that they are in the market not just for the short term, right? Your first 1,000 orders is not going to make them a billionaire, right? It's post a 1,000, 10,000, 100,000, and then boom, suddenly you have a hit in your hands, you're selling 10 million a year. So looking at it like a partnership, and build that rapport with your suppliers, and share as much detail as you're comfortable with them, so that they feel like they have a skin in your company, right? They want to share the journey with you. So I talk a lot about partnerships and building that relationship.
Yeah, I'd say pester your manufacturer as much as possible so that they communicate with you. Because a lot of times, like I've been in situations where I send a design and something changes, and then the design doesn't work, and they don't tell you why because they think it's their fault. They get embarrassed. So pester them.
Correct. Or if you have the time, really spend the time to know your vendors. Not just let me talk to my account manager, but no, go there and talk to the account manager's boss or the owner of the factory. They're more likely to extend and be benevolent to you and say, sure, we'll give you some terms so that you can get over the hump. But of course, there are businessmen that said, nope, I'm not taking any risk, you're out of luck. But part of that also is to make sure you have good risk management in play, so that when vendor A falls out because of terms, you have vendor B that's more willing to play. But of course, that requires time and effort and resources to build out.
All right, well, we're going to wrap things up here a little bit, but you guys both have some very cool tools, the Product Planner, the BOM, and TPM, and do you guys want to talk a little bit more about those?
Sure. So again, just going back to some of the earlier observations we had where it's so important to have a good bill of materials, what we saw is every company that would come to us would have a different format for the BOM. And it became the Babel problem that, you know, it's very difficult to run a good RFQ with the factory because they spend all the time scrubbing it to just get the information they need to determine if they want to quote on it or not. The factory's having trouble keeping track of what version they're actually building. So based on that, at Dragon, we were lucky we ended up raising some money to enable us to add a software team and build this thing called Product Planner, which is designed to be a lot more capable than an Excel sort of bill of materials, but a lot easier to use than installing enterprise level software. So if you're interested, it's just at dragoninnovation.com/product planner, and it keeps track of MOQs. It can give you this cash flow report, which is pretty cool. So if you enter all of your BOM data in there, and we'll actually do that for you, you can pretty much just hit a button and it lets you do scenario planning. So what if I got net 0, if I got net 30, if I air ship it, if I sea ship it, if I have to prepay for my components, and it gives you a pretty picture saying how much capital you need. So you go in and you've changed an unknown unknown into at least a known unknown, and then you can play around with that. So we find that that's hopefully adding some value for some companies, just again, because if you run out of money, you're done. So we wanted to help that not happen.
It was mentioned earlier as when your team size reaches maybe around 10 people, communication becomes an issue. And I think that's roughly the right number that we see. You get to 10, 20 people. And when you were 3 people or 4 people, you could just sit around the desk and email to each other, and you pretty much could all be in sync. As you get to a larger size, you need to think about adding some sort of project management, someone whose job it is, the primary job it is to make sure that the project is going forward, not is my technology working right or is my department doing what it should do, is who is owning the project, who's thinking about that project every day, making sure that things are being done in the right order, in the right way, and everybody's talking to each other. And that can be a remarkably complicated thing, it seems, to make sure that everybody knows what the other people are working on. And that also then leads into things like documentation, is do you have any kind of control over the documents you're creating? Are you maintaining versions? Does everybody have access to them? So as you reach that size, as you're kind of scaling up in your development and adding those people, think about adding project management, technical project management, people who can help you make sure you're getting through your process.
It's been an honor, you guys, really. Thanks so much for your time and sharing your thoughts here with our community.